All right, it is 8 o'clock. So this is the first time I've ever done a virtual conference. So I hope I hope everyone's expectations are met here. It's kind of weird giving a talk without an audience present. So bear with my terrible jokes. Welcome to Elasticsearch Data Exploration in your terminal. I'm your host, Brad Lhotsky. These slides are already up on SpeakerDeck. I have a tiny URL here if you want to follow along there. There's a possibility they're not done processing yet, but I will make sure that after this talk, everything is working at that link. I also added it to the wiki, so you can find the slides there. So the first thing that you're going to be asking yourself is, why do we want to bring Elasticsearch into the terminal? We already have a lot of different interfaces to Elasticsearch, so why go ahead and add terminal in? We have Kibana, and Kibana is developed at lockstep with Elasticsearch. It's developed by Elastic. Surely it's representative of all your graphing and data exploration needs. For me, I found Kibana a little bit difficult to work with, and also difficult to teach people who aren't super technical how to build graphs, how to combine visualizations and create dashboards. And it's just working with the tool feels slower and less intuitive than some other tools. There's Grafana. Grafana is pretty awesome. I love this tool. It's my go-to for doing dashboards and graphs. You can combine data sources on graphs or dashboards, so you can have data coming in from Graphite, from SQL databases, from Influx, Prometheus, and Elasticsearch. It's really, really cool, but still, it's not that great for logging data. They're adding text into a browser with all these fancy widgets and all the visualizations. It feels a little bit clunky. We add in a bunch of scroll bars. So we have a scroll bar for the browser. We have a scroll bar for the individual widgets. Sometimes we get truncated text. We can't really see everything. We don't have good control over how wrapping is handled in a lot of these tools. So it just doesn't feel right. And Grafana recently added a product called Loki into their profile, and Loki is specifically designed for handling log data inside of Grafana. And that, again, meets with those same issues that I have with just logging data in the browser in general, which is it's very difficult to navigate text and to navigate with your keyboard in a browser window. And the other thing is the log exploration pieces in Grafana are really tailored towards Loki. And so there's not as much incentive for the Grafana folks to keep the Elasticsearch components as up-to-date and fluent as the Loki data is. That may not always be the case, but at least in early versions, the Elasticsearch support was really, really terrible. I think it's been getting a lot better, but still we're dealing with the DOM and JS, and we have touchpad gestures, and there's just too much noise happening in the browser. And if we wanted to drag the terminal into this, couldn't we just curl and JQ stuff? And yeah, you could. And if that's your jam, go for it. But I found that to be really annoying and certainly not easy to teach other people who may be in junior positions. And I'm really terrible with GUIs. Anytime a mouse is involved, you might as well have an 85-year-old man with no computer experience sitting in front of the computer. It's just horrible. I'm amazed that this is working today. So I don't like to use mice. And I've never really been effective with apps or browsers. And I see things like Slack as a massive loss of portability and compatibility and openness. I run my browser with so many privacy and security extensions that even when I put them all to permissive mode, there are some websites that just render as a blank white page to me. And I'm not willing to compromise on those security and privacy pieces, so I just can't work with some of those things. The browser is not a good work environment for me. It's slow, bloated, it's prone to distraction. I don't even know how many tabs I have open in my browser right now, but I know the last time I counted, it was around 85. And that's not helping me. Most of those tabs are work related, but I do have a Gmail or a Twitter tab open on occasion. And with browser notifications, it just gets to be very distracting. If you've ever studied user experience and user interface design, you'll know that the top, right, and left corners of your browser are the most visually important. And that's exactly where all of these notifications pop up. So you wind up getting distracted too easily. So the bottom line is I don't see my browser as a workplace. If we look at the terminal, and my use of the terminal and probably some of your uses of the terminal, you have a lot more flexibility and choice. You have a choice of shells. You can heavily customize the shell for your needs. You can create shortcuts for pretty much anything. You have tab autocomplete, read line, and a rich ecosystem of command line tools that are there at your disposal. So it makes performing any operation you could think of very easy. And then, of course, you have access to your favorite programming interpreter like Perl. So you can just ditch stuff into Perl and do stuff there. So aside from things like MUDs, NetHack, and Drug Wars, there's not really a lot of things to distract you in your terminal. This means that the terminal is where I make money. This is what pays my bills. I also have a few principles that I consider guiding lights that have kind of shaped my career and made me who I am today. Very early in my career, I was an intern at Applied Research Laboratories in Aberdeen, which is a contractor for the Army. And I met a programmer who told me that there are a finite number of keystrokes before you die, so use them wisely. That's always stuck with me. I've always thought about that anytime I've typed the same command twice, like, should I be doing this? Should I be writing a script to do this? So that's constantly in my mind. And I also add my corollary to that, which is there's a finite distance you can mouse or gesture before you die, so use it wisely. The Unix philosophy has been really attractive to me, and it's been really important in my career. It's kind of why I am where I am today, and it's forced me to think of automating myself out of a job. And I've been doing that since 1999, and my backlog is still pretty long, but I am working on more interesting things. And at the heart of the Unix philosophy is this idea of interoperability and openness. So you have to think about your command is going to receive input from a user, but that user could also be a command. And then your output could be used to be sent to another command. So when you start thinking about that command line API and creating these pipelines for workflows, you can get a lot more done. And it allows you to stand on the shoulders of giants. I don't know if anyone's looked at the source code of the sort program, but it's really efficient. It's one of the most efficient implementations of sorting algorithms that you can come across. And there are so many different features in just that one program. If you don't know what the sort-h flag is, for instance, check that out. I've learned that recently, and it changed my life. So there's a lot of really cool utilities inside of the Unix POSIX environment that allow you to be more effective. And then there's Perl. I'm not ashamed to say I love it. I've been using it professionally for 20 years. It dominated the 90s due to its ubiquity and ease of use. It's a well thought out language that mimics the sloppiness and unpredictability of natural language. And what this means is the language grows with you. You can start out writing bad code that works. And as you learn more and more about the language, your code can become more efficient and you're never wanting for features. Plus, we have the CPAN, and that's just amazing. While I was working at Booking, I learned the importance of being able to ask a data store arbitrary questions. There's something to be said about a well-defined, purpose-built data store that does one thing well and is super performant. That can be in a critical path. But if you need to be able to explore the data in a data store, it needs to be sloppy and unpredictable, so that you can ask these arbitrary questions, because there's a lot of power in there, and you can use that as a jumping off point. You can use these, you can use a data store that's flexible like this, to house just a little bit of your data, so that you can figure out what are the important questions we want to ask this. And then you can build a purpose-built data store that'll be highly performant for those questions. But not having that ability to just turn the data upside down and sideways and join it with other data and merge it and aggregate, you're going to be not able to answer those questions, and you're going to be less effective at your job. This is one of the most important things that I learned while I was working at Booking. All of this led me to see the power of Elasticsearch really early. Booking adopted Elasticsearch probably in the 2015, 2016 days. And we were using it for front-end search and disambiguation. And I was at the time working in security, trying to find what's called a security information and event management system, which is a SIM. And I came across early versions of Graylog and Logstash, which used Elasticsearch as a data store. And since we already had Elasticsearch in the infrastructure and I was supporting it, there was no business friction for me testing these things out. And I adopted it and quickly was just blown away by how much data was now available, what the questions I could answer. It was nothing else had ever come close. The corollary I could think of is people who've had experience working with Splunk the first time you worked with Splunk. It was very similar to that. The issue was Elasticsearch wasn't very CLI or ops friendly at this time. I was responsible for a very fragile but very profitable Elasticsearch cluster at Booking, and the lack of monitoring and operations integrations really hurt us. When the Elasticsearch cluster went down, it meant we were losing money. So we needed a solution. We needed something that could integrate with our existing operations tools and provide more introspection. So after suffering a few outages, I worked closely with my colleagues at Booking, and Shai Bannon, the creator of Elasticsearch, he was working with us at the time to figure out what was important to monitor and what were the things we needed to do to keep the cluster healthy. And so I started app Elasticsearch Utilities as a functional library of monitoring and operations tools. So the main tools were monitoring, maintenance, status information, so admins could run commands and see what's going on with the cluster. But I built it all with a reusable functional library. So everything was functional, and that, because it was aimed at operations people, the idea was to be able to write quick one-off scripts without having to get too deep into documentation. So everything was very straightforward. The tools were built version agnostic with translations in place as we upgraded versions of Elasticsearch, so that we didn't have to rewrite code. The code could stay the same forever, and we could migrate to newer versions of Elasticsearch. We used in our logging infrastructure the default Logstash index naming at the time. So a lot of the tools inside of the distribution assume that if you have log data, that it follows this index-y.m.d format. And while I was working on these tools, it became evident to me that I could use the same libraries to get data out of the cluster, the actual data rather than the metadata about how the cluster was working. And that is esearch.pl, and that's what I'm going to talk about today. If you have an Elasticsearch cluster at home and you'd like to follow along, go ahead. I recommend using Perl Brew to install the latest Perl, which is Perl 5.3.4 right now. And then UCPanM, app Elasticsearch Utilities, and you can follow along with some of the examples in the presentation. So this happened in 2012. All of this code predated a lot of the stuff that's currently available in the Elastic ecosystem, but I still feel like esearch.pl is one of the tools that I haven't seen a parallel to, and has really been useful to me and to the people that I've shown it to. The code is compatible with version 0.16 all the way through the latest 7. There's some constraints built into the tooling to make searching safe even for older versions of Elasticsearch that tend to explode under load. Hopefully most people are on to at least 6 right now, if not onto the latest 7. I've been slowly rolling back some of the safety features, but whenever I get a cluster out of memory error, it makes me give pause to pulling back some of the stuff. So if you're developing a tool that you expect other people to use, which was the case for this tool, it's important to have good documentation. So esearch has 2 documentation modes. Help will just give you a quick overview of all the command line switches, and there are a lot of them. And then manual will actually give you a full manual, which includes all of the command line options, all the switches, and examples of how to use each one of them, as well as full examples of these are some searches that we were using in our security and operations teams, and you might find them useful too. esearch defaults to connecting to localhost port 9200. If you need to connect to another host other than that, you just do --host, the name. But of course, like I said, finite number of keystrokes. It has a dot file where you can specify all the connection details. These are all the main connection details. So you can specify the host, the port, the protocol. The default is HTTP. The default port is 9200. Default host is localhost. And then if you use basic authentication with your cluster, you can specify the HTTP username and a path to a script to exec to get the password out of one of your keychains, so that you don't have to provide that all on the command line. As we go through this, these are some assumptions that have been made in the tooling that are just useful to know. Searches are constrained by the calendar index date by default if you're using the default parameter of --base, and --base is a index base name. We assume that you put like data in like named indexes. So here you see --base logstash. That's going to find anything that looks like a logstash index and add that into your query. It defaults to looking at 1 day's worth of data, but you can say --days 7 for opening your scope up to 7 days. The searches will stop after they reach the default -- size, which is 20 results. So if they meet that result, that total number of results in the first index, it won't go back any further. You can use --all to get all the results across the full time span that you specified. Sort order is descending based on the timestamp field. You can override that with --ascending. And if you need to use this tool, I do occasionally use this tool to look at other indexes that don't follow this date format. You can specify that with --index, and you can use an alias or index. You can also provide multiple indexes with commas, and you can use wildcards in the --index. It's just passed to the URL, to the index position and URL. So anything you could do in Kibana or in any other Elastic tool, you can use there. So if we're getting started with let's figure out what's going on. I've got data in Elasticsearch, I know nothing about it. The first thing that I want to do is figure out what are the bases that are available. So when you run esearch bases, what happens is the tool pulls all of the indexes that are available, and then it figures out what they look like based on their index name. And it'll provide you a list of base names that you can then target with the command. In this case, there's 3 simple ones, but if you use data center IDs with your index names, you might see some of that. You might see data center - logstash, and then also logstash, because it'll figure all these things out. Once you have the bases, you might want to say, okay, what is actually in this index? So here I'm saying, look in the syslog index and show me all the fields. And what that might look like, and this may be hard for you to read, it's not super important that you can read every line on here, but we're dumping all the field names. And along with those field names, we're also dumping out the data type so that we have some bearing as to what is in this index. And then at the very last two lines give you a breakdown of what actually happened. So we found 43 fields in one index. And we can see that there are 29 keyword fields, et cetera, et cetera. So we get a summary of what's in this index. So once you know what's in the index, just show me a document, right? I want to see, let me see a sample of what's in there. And for space, I'm just using size 1 so that you can see the full output. But here you can see a few things. First off, in the heading, we see a warning, timestamp field at timestamp not found, using timestamp instead. All these searches are based on the timestamp, so it needs to know which field you're sorting on. So if there's only one timestamp, it can guess that, and it does. And it defaults to guessing the default logstash and Elastic Ecosystem timestamp, which is at timestamp. If it doesn't find that timestamp, it will use the single timestamp field. If there are more than one timestamps in an index, then you'll get an error, and it will list all the timestamp fields and tell you to pick one. So yes, we have data out. It's YAML. We'll get to that in a second. At the bottom, you can see that we get a summary. We're displaying 1 of 3625 results, and it took 0.19 seconds to do that. Again, I don't like to type, so we can specify the default number of days and the default base so that we don't have to specify those on the command line. And timestamp, we can set the timestamp via the command line, or we can add that timestamp again into ESUtils, so that you won't have to provide that hint any longer. What if there's more than one base? Well, that's fine. We don't want you to type too much either. If you add a meta section into the ESUtils, you can say for the logstash base name, we're going to use timestamp at timestamp, but for the rest of our indexes, the default timestamp is timestamp without that at sign. And you can list as many index base names there and timestamps as you need. So back to the output. This is YAML. And what you're saying right now is, Brad, I hate YAML. And yes, I know you want logs. So what we can do is we can tell ESSearch which fields we want to see in the index. So we do that with show, and we give it a comma-separated list of field names. And when we do that, we have logs. This looks very familiar to anyone who's ever tailed a log file. So that's very refreshing. Everyone can breathe a sigh of relief. We have logs from Elasticsearch. Really, the power of Elasticsearch is being able to search things, and we support the Lucene query syntax by default. So in this case, we say that the program field matches SSHD. We can then do this search, and you can see the parameter that I set to the command line, and then down here in the search parameters, I actually get an overview of the exact way that search was provided to the backend. So we see the query string parameter, which matches up with the Elasticsearch documentation for this stuff. But what we do, this tool was built out of security and operations. And we tend to build up queries as we're going along. We narrow in, we hone in on attributes in the logs that we're really interested in. So we start out with a high level overview. We find this needle in a haystack, and then we add that in, and then we see what else is there. So being able to add multiple parameters is important. And a mistake that we made a lot in our early days of working with this tool was forgetting to specify a conjunction, so and, or, to join terms. And we found out that we almost never used or, and we were always using and. So esearch.pl makes away with you having to specify and or, and just assumes that any dangling search term will be joined with an and. So here we have 2 search parameters instead of 1. And you can see in the command line, we are missing that and. That is proper, but down here in the search parameters, it joined that with an and for us so that we don't have to pull our hair out. This just makes, again, fewer keystrokes. If you are one of the people who somehow enjoys oring everything, you can use -- or to change the default operator to or. I would probably advise you to be explicit and use or as inside of your query, because doing the multiple joins gets really weird, and you'd want to use parentheses and all of that stuff to make sure you're doing the right thing. But here, when I use or, again, with the same parameters that I had before, I get a much wider search scope, but you can see that we joined with or instead of joining with and. And if you're of the opinion that you want to do all this stuff in the command line anyways, and you want to use JQ to do that, that's cool. I've got your back there. If you specify --JQ, all the decorations that we've seen in the previous slides will be removed, and all you'll get back are the actual raw document results in new line delimited JSON form, and then you can use your JQ tools to do all kinds of stuff. So here you can see that we just said use JQ format, and boom, now we can just extract out the IP addresses. As we were working with this tool, it started to become more difficult to represent some of the queries we wanted to make, because our knowledge of Elasticsearch was growing and our use cases were growing. So we needed to do more complex things. So as that happened, I started adding a plugin system to this tool so that we could take tokens that were coming in on the command line and expand them out into Elasticsearch conventions in the back end of the query. The first one is very simple. It was a mistake we made a lot, which was not capitalizing and or not. So if you don't capitalize and or not, it will be capitalized for you so that it passes the Lucene syntax and does the thing that you expect it to do. This is a do what I mean kind of principle that I borrow heavily from Perl. So here you can see I have a lowercase not in my parameter. And then when I actually go down to the search parameter, the search parameter has been uppercase so that it does the right thing. Security and operations people work a lot with IP addresses, and we like to group those IP addresses using CIDR notation. So that's not something that's natively supported by Elasticsearch. You need to use a range query. So if Elasticsearch, if esearch.pl determines that there is a token that looks like CIDR notation in your query, it will go ahead and it'll expand that to a range query. So here you can see that I specified in CIDR notation. Another thing that I wanted to show is if you specify in a -- show a field that is actually contains structured data, when you do the show, you'll get that structured data back. So it'll JSONify that structured data. And here you can see on the search parameters that our CIDR notation was transformed into a native Elasticsearch range query, and the villagers rejoiced. Range queries are supported for numeric data as well, and for dates. So you can specify greater than, less than, greater than, equal to, less than, equal to. The catch here is these characters have special meaning in the shell, so you need to shell escape them. So here we do a range query of greater than 5, and it's transformed into a native range query in esearch.pl. Some things are hard to escape. I don't know if anyone has ever attempted to search Elasticsearch for a user agent without using term filter and using Lucene query syntax, but it is maddening. So one of the optimizations that I added was if you prefix a field with an equal sign, which you'll need to escape in ZSH with a backslash because equal sign has special meaning in ZSH. Then everything that comes after the field name will be promoted to a terms query. So here we see that I specified the equal, and then down in the search parameters, instead of being a query string query, we now have a term query, and we match the document that actually has that exact match. There's a few underscore search parameters that Lucene syntax supports. Underscore exists, underscore missing. So one of the things that we were doing is underscore prefix, and it didn't exist. So I created it. If you do underscore prefix, you will get the translation to a prefix query automatically. Again, security and operations people, we carry around text files full of data, and sometimes we need to take a column of that data and then use that as a feed for our query. So I added the support for being able to pull data out of structured text files. So this will work with tab delimited files, white space delimited files, comma separated files, and JSON, a new line delimited JSON files. So in these few examples, we have a file called badguys.dat, which has some IP addresses in it. What it'll do is it'll columnize the data, and then it will default to pulling the last column of the data, pulling all those rows, uniquing them, and then translating that into a terms query. If you don't want the last column, but you want a different column, you can specify that using the array, zero-based array syntax, because it's just an array and you can access any of the array syntax there. So let's take a look at what that looks like. So here I have badguys.dat, and I have some IP addresses in the last column. So what I do is I run the search program IP tables, source IP badguys.dat, and then show these fields. And then you can see here in the search parameters that I have a terms query, and it contains all the IP addresses that were in my badguys.dat file. This also works with new line delimited JSON. Of course, you probably have like hash data or object data in those files. So you would use the key name in between the brackets. If you have nested keys, you can use the dot to represent the nesting. All right. But the real power of Elasticsearch isn't in these like arbitrary queries. It's fun, but looking at larger groups of data and aggregating that data into ways that we can understand is really what we want. So Elasticsearch, esearch.pl comes with the ability to do aggregations. There's a couple of caveats with aggregations because, like I said, this was built in a very exploding version of Elasticsearch back when they were called facets, and they would kill your cluster if you did them. So there are a few restrictions. I've backed off a lot of them, and I'm still working on what makes sense to remove so that this default experience is positive for users, as well as figuring out how to make some, super user switches that say, I'm okay with if you kill my cluster. So they default to running the aggregations on those calendar day indexes instead of doing them against the full range. You'll do them as the result would be parsed. So we do the first aggregation set on the first day's worth of data, and then the second aggregation set on the second day's worth of data, and combine those results. It's not perfect, but it did protect the cluster from exploding by not engaging as many shards at one time. The top aggregation has to be a bucket aggregation. Right now, terms and significant terms are really the ones that work best. The rest of the bucket aggregations haven't been quite as well tested. And it is currently limited to 2 levels of aggregations with a special case for a 3rd level, but I'm looking at rolling that back as well. So to do that, we just do esearch.pl top program to get the top program name. That'll give us top 20 because that's the default size. If we want to change the number of results we're seeing, we can use --size any number, limit, and all of these things are the same parameter. So we can get the top 50 if we wanted to. So if we do this search to see the top program, we get the list of top programs. Down here, we see that we're displaying 20 of 41. So there are 41 distinct programs, and we're displaying the top 20 of them, and our query matched 158,000 documents. The special case aggregation that's supported beyond 2 levels of aggregation is interval. If we wanted if we see a spike in something, sometimes we want to be able to say what caused that spike or what changed in that spike. So we might do an interval of 1 hour, interval of 10 minutes, an interval of 5 minutes to see what changed in the top results as we hit this spike to help narrow in on it. And what that looks like in the terminal is each Each line has a bucket that tells you the start point of the bucket, and then the count of the objects inside of that bucket. So here you can see we have all the buckets for this one range, for this one index. We can support other aggregation levels. So if we wanted to get the top action with the top 3 source countries, we can do that. This sub-aggregation is limited to 3 results per set by default, but you can change that by using a colon after the field name to give you a count of the sub-aggregations you'd like to see. So the first example is the top actions, so it'd be top 20 actions with the top 3 source IPs or source countries. So that would give you 60 results. And then the bottom one would give you 200 results. So also 3 was chosen just because it would help minimize the amount of data on your screen, so you could actually make some sort of distinction about what you wanted to do with that data. And what that looks like is, here I've done a -N3 just for conciseness to fit in this slide without tons of data. Here we can see blocks of 3. The action here is block. There are 9758 block actions. And then we can get a breakdown by source IP. And so we can see that this source IP had 1,700 of those blocks. And then the next block is pass. We can see all of the top 3 source IPs for the pass action as well. If we wanted to change that, like I said, to get 10 results, I dropped the -N to 1, so we're only seeing the top, which is block. But now we get 10 source IPs of the top for that action. Of course, you're not always looking for the top by document count. Sometimes you want to use, you want to look at the top by some other parameter. So in this case, if we wanted to see the top source IP by distinct destination countries, we can say, give me the top source IP by cardinality dest GeoIP country. We can also use any single stat aggregation. So we can also use sum, min, max, median, and another example here of using sum with the amount of data. So here we have the cardinality of the destination GeoIP country, and we can see that the top result has hit 45 countries in 1,800 documents. And then the next one down has hit 14 countries in 89 documents. And then you can see there's this first column is the cardinality, the second column is the number of documents. So we're sorting first by the cardinality, and then the second one is by number of documents. So you can still see the most popular documents there. And then again, here's an example using that sum where we count the data, and we can see the top dest IP with by the sum. And if we wanted to, we can kind of put these two things together so that we can, maybe have a little bit of an understanding of what's going on. So we can look at the top source IP by the most amount of data sent out, and then look at the top hit for that destination IP. So we get a little bit more context on what's going on. And what that looks like is this. We have the sum of the data, and then we have the number of hits followed by a percentage of the total number of documents, the source IP, and then we get this dest IP, and then the number of documents, and the percentage of that bucket that makes that the percentage of the encompassing bucket. So in this case, it's 28% of the total data for this source IP of 148.251.1468. So that helps us kind of get some data, but we might be interested in statistical analysis of some of the data. So like this index that I'm working with, I know that the total time field is actually the total time for parsing the raw syslog element into a structured document. So If I were looking at the performance of these parsers, the parsers are keyed off the program. So I would want to see all the programs, and I want to see the slowest program parser. So I would use by average total time, and then I can get stats total time. So I can say, give me the top program by average total time with the stats from the total time. And this is a little bit more verbose output because there's a lot of data to display. So here we can see that the IP tables program parser is the slowest, and its average time is about 0.013 seconds. And it's 241 documents, and the minimum amount of time is 0.006. And then the max time is 0.02, and the total time spent to that parser is 3 seconds. So this gives us kind of an overview of what the parsing looks like for these parsers. But of course, if you are a fan of statistics, you know that's not, this descriptive statistics do not stop at average, min, and max. And percentiles are a much better way of viewing data. So here we can specify percentiles of the total time and then add a third parameter, which are the percentiles we want to see. In this case, the median, or 50, 90, and 99. And then we get that data as well. So we can get a better sense of the shape of the data. But if we wanted to really know the data, we would want to look at a histogram of the data. And so esearch.pl provides a way to display histograms of data in the terminal. It's not yet bar graphs, but it's something. And one day it may be bar graphs. It's on the list. So here I'm saying I want a histogram of the total time, and I want each bucket of the histogram to represent 0.01 seconds. And this is what you end up with. You will get a result. So here you can see the top result is the IP tables. We have 3 buckets in the histogram from 0 to 0.01, 0.01 to 0.02, and 0.02 to 0.03. So we get an overview of how many documents were in each one of these buckets, and we can see that the most documents were in 0.01. So we know between 0.01 and 0.02 is where it takes the most, that's where most of the documents fall. So that can be helpful in understanding the performance of some things that you have in Elasticsearch. You can also do significant terms in the top aggregation. I didn't really have a good example to show of this in the indexes that I was using for demo, but you can also specify the background filter. So in the top one, the background is the rest of the data set. And then in the second field here, when we use a BG filter, the background that's being used for computation of significance is limited to documents that match the source IP or source country of US. So that's also handy when you're doing security and operations stuff. One more thing, or more, I'm not sure. This is built with CLI helpers. It's a library for developing command line utilities. It will auto detect whether or not you have get colors enabled and enable color output, which you've seen in my screens. It provides the -- data file, which when data is tagged in an output with data, it will output it to that data file, and it supports app-no paste. App-no paste will only, the CLI helpers will only paste to private app-no paste services unless you specify -- no paste public, and then it will allow you to paste to a public server. So what I've done is just subclassed a app-no paste service object for my internal paste service flagged as private, and I use that to share data with my colleagues. So here's an example where I do a top aggregation, I do a top search, and then down here I specify data file inside the house.dat. And you may be familiar with that because you saw badguys.dat. That's exactly the kind of query that would create that type of file. So now I can then use that output as the input to the next query. So now I can get all the actions that this actor has taken, not just the ones that I got from the threat feed. And then if I want to share that information with my colleagues, I can just do -- no paste, and it will paste it to my internal paste bin, and we have the document there for sharing. This is also a Perl library that I've been working on and used. It's been becoming more and more OO so that it's reusable to make it a little bit easier to work with. App Elasticsearch Utilities query string provides all of the cool query string expansion that I showed you. App Elasticsearch query provides an interface around just doing a very simple around doing queries. And all these are all from the config and command line options of App Elasticsearch utility. So when you build a utility with these modules, you have --host, you have the basic user authentication, you have bases, you have all those things available to you. So let's see if this works. I've got a few minutes, maybe a minute. Let's see if I can.
You're good on time.
Okay. Let's do. Well, let's just do this. Okay. So I wanted to show the library stuff just really quick. And everyone can see this. It's working. Okay, so here's the App Elasticsearch utilities query string. I just initialize the object, and then I pass anything that comes in on the command line to expand query string, which does the automatic query string expansion. I create an aggregation, a terms aggregation on the field program of size 1, execute the results, print the results, and then show you what the query was. So if I do that, if I just run that, you can see I got, this is the raw result that came back from Elasticsearch. And then here's the query. So the thing is, like, we can still do the things that I mentioned before since we used query string instead of query. So here I have query bool must range crit g greater than 5. So we have access to all this stuff. We can say things like, source IP 10.0.0.0/8. And I get my range query. So you get all of that stuff for free by using these libraries. The next thing I wanted to show is like multiple levels of aggregation become easier. So in this case, what I'm doing here is I'm creating the innermost aggregation first, and then I'm wrapping that aggregation in a second aggregation. So it's building it from the inside of the onion out, of what it will look like. So let's do that one. So here I have my outer aggregation was hostname, and I get the hostname of pfSense, and the inner bucket is program. I just did one so that the results would fit into these terminals, but you could imagine that expanding out to multiple ones. And again, since this is using query string, I can apply those changes. I didn't output the query here, but you can see that the name changed from pfSense to Janus and the program to OSEC. Another thing that I do a lot when I'm writing scripts to generate reports from data out of Elasticsearch, which this library works really well with, is I'd like to create a really complex query, and this is a stand-in for a complex query, and then in a loop, I want to look at that query against different parameters. So in this case, all I'm going to do is change the host name, but I'm going to introduce a stash. So I stash this Boolean thing, I execute it, and the next time I call stash, that part of the query is just replaced. So the rest of my query stays intact, but the stash is replaced. And then what that looks like is this. So now I have the same aggregation stuff. I didn't have to change anything, and I get that. So those are kind of nice. And I guess the other thing that I wanted to show is this stuff does actually work. This log fields, we get all the field data. And I guess one thing that I didn't show in here that everyone really needs if they're going to be doing any type of data with any type of logging is a feature, and this is a very low volume. It should be a low volume, so this might not be as glorious as it could be. Everyone loves the tail logs in their command because that's, as we know, the most effective way to find out what's going on in your infrastructure is to tail log files. So you can, if you use show, you can do --tail, and you can tail logs. So all those people that are curmudgeonly not wanting to get into the Elasticsearch ecosystem that must tail a log file in a command line in a shell to see what's going on, they can be satisfied as well. So that's kind of all I had right now. I wanted to know if I wanted to leave time for questions if there were any questions. But yeah, that is app Elasticsearch utilities. The only other things I have here are back. Just a real quick note about future plans for arbitrary levels of nesting, JSON output for aggregations, better support for nested documents, and arbitrary data joins, anything you can think of. And here's my contact information. So yeah, are we doing questions?
Absolutely.
Okay, yeah, the floor is yours.
We got 5 minutes.
Okay. Is there oh, there's a chat. I didn't have chat open. So someone did say many programs behave differently depending on the existence or not of a config file. Is this any different? So the esearch.pl will use .esutils.yaml if it exists. If not, it will default to searching localhost. Really, the only main parameters that will change are the host that you're connecting to, the port that you're connecting to, and then the default base and timestamps. Those are really the only information that esearch needs to understand to be able to do its job. So those are the only behavioral changes that change based on the existence of that file or not.
That comment, Brad, was in reference to the feature of being able to read the last column out of a CSV, for example, and how the command line operates differently if there's a file in your local directory of that name versus using it as a search term.
Oh, right. So you can specify a fully qualified path. So you can an absolute path, or in my examples, I just use files that are relative to the local directory. You do have to specify .dat, .txt, .csv, or .json as your suffixes, because it will only look for those in the search terms. And then if it finds the document, the file on your file system where you specified with the default search path being current working directory, it will do the thing. If it does not find it, it will pass it along as a search term. So that's part of the reason why the tool gives you one of the last lines of the output is the search parameters that it used. So you can see, oh, that didn't expand, that actually searched directly for that name. Yeah. Yeah, so there's a lot of documentation. So I'm going to assume that everyone's read the documentation, doesn't have any questions. But if you do have any questions, feel free to reach out to me. On Twitter sometimes. I've really taken a step back from online stuff to kind of lower the anxiety levels. But you can hit me up on Twitter. And if you want to have a more direct conversation, hit me up on Twitter. I'll give you my signal information so you can reach me almost any hour of the day if you're using this tool. It's something that has been a lot of fun to work with and a lot of fun to talk about. So thank you for the opportunity to talk about it.